Today we're going to discuss trig identities. Some of these identities we've already talked about. We know them so far as the six trig functions: sine, cosine, tangent, cosecant, secant, cotangent. And the relationship between them are reciprocals, as stated in the slide. We know that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So likewise, we could say the reciprocal of cosecant is sine, the reciprocal of secant is cosine, and the reciprocal of cotangent is tangent. Tangent again is sine over cosine. Likewise, since we know that cotangent is the reciprocal of that, we could say that cotangent is equal to the cosine of x over the sine of x. And these are all substitutions we can make if we see them in a problem and we want to make it smaller. There are some other identities called the Pythagorean identities, using obviously the Pythagorean theorem. We know that in a circle, for any point xy, that circle has an equation of x squared plus y squared is equal to r squared. You should have seen that in geometry. If not, well, now you've seen it. But in the unit circle, we know that that radius is 1, so we can say that x squared plus y squared is 1 squared, which is 1. We also found out that in the unit circle that the cosine is equivalent to x and the sine is equivalent to y. So therefore, we can say that sine squared plus cosine squared is equal to 1. And then by doing some subtraction, in other words, subtracting either one of these to the other side, we get 1 minus cosine squared equals sine squared, and 1 minus sine squared equals cosine squared. These are all identities we can use at a given time to simplify a problem. And I'll explain that in a minute. Now there are more Pythagorean identities. If we were to take the sine squared plus cosine squared is equal to 1 and divide each term by sine squared, I get 1. Cosine over sine is cotangent, but it's squared. And 1 over sine squared we just talked about, that's the reciprocal, and gets me a cosecant squared. So here's another Pythagorean identity. But likewise, I can subtract terms to the other side and get cosecant squared minus cotangent squared is equal to 1, and cosecant squared minus 1 is equal to cotangent squared. So we're up to 6 of these Pythagorean identities. Really, all you need to do is know the sine squared plus cosine squared equals 1, and you can generate all of these. There's 3 more we need. Again, take the sine squared plus cosine squared is equal to 1, but this time divide each term by cosine squared. Sine squared over cosine squared is tangent squared. This is 1. The reciprocal of cosine is secant squared. And then I can subtract from to the other side, and we end up with secant squared minus tangent squared equal to 1, and secant squared minus 1 is tangent squared. So now what are we going to do with these? Well, we're going to simplify expressions. Let's start with something we've already done this year. If we simplify something like this, we use algebra to do it. And the algebra we use is, standard algebra. We know we can't reduce the x squared and the 5x's or the 6 and the 14 because they're separated by addition and subtraction. So we'd have to factor this. So if I was to factor that, I get x plus 2, x plus 3. On the bottom, I get x minus 7 and x plus 2. Since those are factors, the x plus 2 reduces, and that large trinomial division reduces to the division of 2 binomials, and it's simpler. So now we're going to do this with trigonometric expressions. So if I'm given the cotangent of x times the secant of x times the sine of x, I want to reduce that as far as it'll go. I know some things here. I know that the cotangent is equal to the cosine of x over the sine of x. I know the secant is the reciprocal of the cosine, and that's all multiplied by the sine of x. And I'll just put that over 1 for kicks. And so now you can see this is a multiplication, and I've got reductions everywhere. The sines reduce, the cosines reduce, and I'm left with 1. Here's another problem. Now there's a lot of ways to handle these. I'll do this 2 ways just for fun. We could say this is secant, which is the reciprocal of cosine. Cotangent is cosine over sine minus cotangent, which is the cosine over sine, times the cosine. So this ends up reducing. I get basically 1 over sine of x minus cosine squared over sine. Common denominator, I can add, so this is 1 minus cosine squared of x over sine of x. And here's our first Pythagorean identity looking at us. 1 minus cosine squared is equal to sine squared over sine, which is equivalent to sine because one of those signs reduces. That's one way to get that problem done. The other way, let's see, I can do this. I see a cotangent in common, which is factorable because it's a GCF, and I'm left with secant of x minus cosine of x. Cotangent of x, that's 1 over cosine of x minus cosine of x. I think this is actually a little tougher. Next we can say this is a fraction, and I have to have common denominators, so I have cotangent, which I'm going to change to cosine of x over sine of x, 1 minus cosine squared of x over cosine of x. And I got that because I know that I have to have cosine as my denominator here, so I multiply by cosine over cosine. Again, I know that this is sine squared of x, 1 minus cosine squared. You're still going to have that knowledge working for you. So this is sine squared of x over cosine of x. And there's a reduction again. The cosines go, one of the sines go, and I'm left with sine of x. So however you see it, I would go with it. Here I'm definitely going to choose to go ahead and use a factorable GCF of sine squared. So I'll pull out a sine squared of x, leaving me with 1 minus or 1 plus cotangent squared. And you'll notice here, again, I mean, I've got some options, but I know that 1 plus cotangent squared is cosecant squared. And that's multiplied by sine squared. Now we know that cosecant squared is 1 over sine squared. Which ends up with 1. Again, in front of me, I see I've got some Pythagorean identities. 1 plus tan squared, there should be an x here, is secant squared. And 1 minus sine squared is cosine squared. Again, secant is the reciprocal of cosine. So I end up again with 1. You're seeing a lot of these reduce to 1. That's not always going to be the case. Could just reduce to a trig function like in one of the earlier problems. So here's another problem. Whoops. Here's another problem. I can do a couple of things here. I could go ahead and distribute this tangent through, or I can change everything into sines and cosines, which, you know, a lot of people tend to do. Let's just go ahead and change everything to sines and cosines. So I'll make that sine of x over cosine of x. This is 1 over sine of x minus sine of x over 1. And then I'll distribute this. Notice the signs are going to go, which leaves me with 1 over cosine x. In this case, I get minus sine squared of x over cosine of x. And you'll see that since I have a common denominator, I get 1 minus sine squared of x over cosine of x. This top is a Pythagorean identity of cosine squared of x over cosine of x is equal to cosine of x. So here's another. Right off the bat, when I see these squareds in here, I'm looking for a Pythagorean identity right off the bat. 1 plus tan squared I know is secant squared. And I've got cotangent of x and tangent of x. Now, there's a couple different ways, again, to look at this problem. I'll go number 1, number 2. One way is to change everything into sines and cosines right off the bat. So let's go ahead and do that. You could say that cotangent is sine cosine over sine, and the secant squared is basically the reciprocal of cosine, so that's 1 over cosine squared of x. That's all over sine of x over cosine of x. Now, this is a division, complex fraction. We can multiply by the reciprocal. When I multiply by the reciprocal, I get cosine squared over sine squared and 1 over cosine squared of x. Notice the cosine squareds go, leaving me with 1 over sine squared of x, which is equal to cosecant squared of x. Second way to get this problem done, here's what I see when I look at this problem. I see this is the same as 1 over tangent of x times cotangent of x times secant squared of x, like so. I know the reciprocal of tangent is cotangent, so I see now cotangent, I see now the cotangent of x times the cotangent of x times the secant squared of x. Cotangent times cotangent is cotangent squared of x times the secant of x. I know that the cotangent squared is the same as the cosine squared over the sine squared and 1 over the cosine squared, and you'll see right now I'm in the same spot. It's just a different way of getting there. And I end up with 1 over sine squared, which is cosecant squared. So basically we're trying to reduce these down to a singular number, or a singular identity value. Alright, that's about it. Just make sure you know your Pythagoreans and your reciprocals, and then it's just basic algebra going from there.